So, to continue the conceptual bit of data analysis, I will talk about significance testing. As I have said several times in the course of this all these chapters, and as my colleague Professor Punima has also said a couple of times, there is a general misconception that market research is basically statistics, it's basically statistical analysis. I've even seen market research textbooks by professors which is all about, normal distribution curve and various formulae and so on and so forth. It's important to understand that market research is primarily about people. It's not about numbers. It is primarily about consumer behavior, it's about consumer understanding, and statistics is a useful tool that helps us to understand consumers better, that helps us to analyze their responses better. Having said that, we do need to understand statistics well. In an earlier chapter, before we talked about sampling, we talked about normal distribution, we talked about sampling distribution, we talked about concepts like confidence interval, we talked about the n equal to 30 golden rule, we talked about the 95%, 99%, 67% principles that apply to the normal distribution and so forth. It's actually the same set of principles that get carried forward when we talk about significance testing. Something I want to establish here before I start talking about the concepts. I believe you can understand significance testing without understanding numbers. As in, you can just get a working knowledge of, in this situation, I need to do this test, I need to read the result in this fashion. And you can do that without too much understanding of numbers. And what I'm going to be focusing on now is the pure conceptual application of significance testing. Just about anybody can run a significance test if you're given a computer, if you're given a formula. Anybody can run a chi-square test. Anybody can run a cluster analysis. Anybody can run a factor analysis if you're given a powerful enough computer, if you're given a set of programs and a set of commands which you can follow. The real skill is not in running the test. The real skill is in knowing which test to run in which situation. Right? So we will talk about those things and we will talk less about running the test because, again, as I keep saying, your data analytics students, you will be covering statistics a lot deeper in some other paper. So our focus is on market research and consumer understanding. So we'll talk more about which test to use when. Right? But let's first see what is significance testing. I have no slides here, right? I just have this whiteboard kind of thing which I'm going to use. Let us say we do a study amongst 200 consumers, right? And we find out what is their average income. And from the sample of 200, we get an average income of 10,000 rupees per person. Okay. Now, because it is a sample survey, there is something called sampling error, which is determined by the various formulae that we have studied earlier when we talked about sampling distribution and normal distribution. So, when we say the sample survey indicates that the average income is 10,000 rupees, what we really are saying is we are fairly confident that the average income of people is 10,000 rupees plus or minus some small amount. This is a confidence interval. So some amount A1 less than 10,000 less than A2. This is the range of the actual income. Now A1 minus 10,000 and A2 minus 10,000 are governed by formulae. When the sample size is large, that this range that we're talking about tends to be small. So significance testing comes from this. Let us say we have we have a sample of 200 MBAs, and we have a sample of 200 engineers. Let's say they're all working in software companies. Now let's say the 200 MBAs we find have an average income of 10,000 rupees, and the 200 engineers have an average income of 10,200 rupees. So, do we conclude that the engineers have a higher average income? On the face of it, yes. But is that finding statistically significant? Is a question that comes to us, right? Now, why does that question come to us? Because 10,000 itself is some A1 to A2. It is somewhere between 10,000 minus some figure and 10,000 plus some figure, right? It is a range. It's not exactly 10,000. It's maybe 9,800 or 10,200 or something. Likewise, 10,200 is also a range between B1 and B2, right? Now, let's assume, just for argument's sake, that the range is 9,800 to 10,200. This is A1, this is A2. And let's assume that B1 is 10,050 and B2 is 10,395. So this is 10,200 is somewhere here, 10,000 is somewhere here, right? Now, as you can see, there is an overlap here. So it is possible in theory that the real average of this 2,000 engineers is somewhere here, and the real average of this 2,200 MBAs is somewhere here. In which case they're equal. They're within the range which comes within the sampling error, right? This is the essence of significance testing. Now, it is also possible that the 10,000 people are somewhere here. I mean, the engineers, 200 engineers are somewhere here, and the 200 MBAs are somewhere here. In which case it is different because it is outside the range. But it's possible that they are here and here, in which case it is similar because they're inside the range. Now, which is the case? Which is the truth? How do we know which is the reality? Is it like outside the range or is it inside the range? Which is the actual reality of the situation, right? So significance testing will tell us the probability of this situation occurring, the probability of this situation occurring. And based on the probability, we can conclude which of them is more likely to be accurate. Now, some of you will understand this intuitively because that's the way the subject is. Some people understand it intuitively. Some of you will understand it when you listen to the last 3 or 4 minutes once, twice, thrice, 4 times. Because that's the way the subject is. Some of you will require repeated explanations, repeated listening to understand it. Some of you will not get it intuitively, right? It doesn't mean you're not good at statistics. It doesn't mean you're less intelligent. It doesn't mean your numerical skills are poor. It really doesn't matter. Believe me, it doesn't matter. Because what I'm going to talk about after this, you don't need to understand this to understand what I'm going to talk about after this. You can still be a perfectly adequate significance testing person for market research purposes without understanding this intuitively. It is of course better that you understand it intuitively, but even if you don't, it's not the end of the world, it's not too much of a problem, right? So, assuming that either you have got it or on repeat exposures you will get it, I will go forward to the next stage. Go to edit. So this, I know, I think it's easier to escape and create one more slide. So a nice clean whiteboard now. So what we are doing in significance testing really is we observe or find some difference between the values in two sets or even more than two sets. We observe and find some difference. Like the mean is 10,000 rupees here and 10,200 rupees there. We observe the difference. Significance testing is telling us what is the probability this observed difference can occur just because of chance. By chance, I mean because it is a random sample and not a census, because there is something called sampling error, etc. What is the probability that is difference that we're observing between 10,000 and 10,200? What is the probability that this difference can occur only because it is a sampling survey? Meaning it is not a real difference. It is because we have done a sample survey that we are observing two different figures. If in reality there's no difference, what is the probability of that? Now, if the probability is high that such a difference can come only because it is a sample survey, then we would conclude that in reality those two numbers are the same. If the probability is low that the difference can occur only because of probability, only because of chance, if the likelihood is low that the difference can occur only because of chance, then we conclude that in reality the figures are indeed different. Right? This is clear. I'll repeat this. If the probability is high that the observed difference can occur purely through chance, then we conclude that there is no real difference between the two data points. On the other hand, if the probability is low that the observed difference can occur purely through chance, then we conclude that there is a real difference, that rather that the difference we observed in between the two data points, that difference is real and a phenomenon of the market, and it has not come just because it is a sample survey. This is significance testing. So significance testing allows us to calculate this probability, right? And this probability it calculates taking basically two main things: the sample size based on which we have done the estimation. So in this example it was 200 for both the samples, and the two sets of data that we found. One of them said 10,000, the other said 10,200 in this particular example, and the difference is 200. Right? It takes these two things. It calculates. It calculates something called variance. It calculates, various things, and then it tells us, it gives us a figure P, the likelihood the probability that this combination of figures given the sample size can occur only because of chance. Alright? Now, for most market research studies, we use something called 95% confidence. This means that if the p-value that we calculate from the test, which a software will do for you. You don't need to know the formula these days. You can just use the software. If the p-value that we calculate is less than or equal to 0.05, right? It means the chances are less than or equal to 5% that the difference we have observed, given the sample size, is only due to chance. The chances are less than 5%. And therefore, we would conclude that this data, that this difference of 10,000 and 10,200 is significant with 95% confidence. Significant and 95% confidence. Right? If P is so let's say, for example, if P is equal to 0.03, that means it is less than 0.05. And therefore, we will say that this difference we have observed is significant at 95%. If, on the other hand, if P is equal to 0.07, that means it is greater than 0.05. Therefore, there's a 7% chance that this observed figure can come just due to probability. And therefore, it is not significant at 95%. It is not significant. However, some researchers will use 90%. And since it is 0.07, which is less than 0.0, which is less than 0.1, right? 7% is less than 10%. Therefore, it is significant at 90%. Right? Let me repeat this. The significance test that we run calculates the probability that the difference we have observed can occur only due to chance, given the particular combination of sample size we have taken, etc., etc. Right? Given those situations, this combination of sample size, this observed difference, this level of variation in the data, given those inputs, the significance test will tell us whether the difference we have observed can occur only due to, what is the probability that it can occur only due to chance. Now, if that probability is less than 0.05, then we conclude that the difference between these two is significant at 95% confidence. If it is let's say 0.07, then we conclude that the findings, the difference is not significant at 95% confidence, but we can go on to say that it is significant at 90% confidence, because 7% is still less than 10%. So, just to make sure that this understanding is very clear, I will just extend this particular example a little bit. Here I am with a fresh page again. Well, let's just intuitively think about this. Let us say our sample size was only 10 MBAs and 10 engineers. And we found this figure of 10,000 and 10,200. Supposing somebody comes to us and says, "This is a finding, can you tell me what is significant?" Won't we all sort of commonsensically say, "Listen, 10 people here, figures can be different. It's not so stable. This can come differently different times. So we can't just conclude that this is really different." Right? So, if 10 becomes 20 and 20, we may still say the same thing. If 20 becomes 50 and 50, then we may say, 50 is a fairly good sample size. Maybe this 10,000 to 10,200 is a real difference. Maybe, we won't know. That's when the doubt creeps into our mind. Now, if this 50 becomes 5,000 and 5,000, then we'll say there's a 5,000 here, 5,000 there. Difference is only 200, but it is significant because this number is so huge, the data must be correct. Right? That's the way this works. So, even a small difference tends to be significant when the sample size is large. Now, on the other hand, let's go back to the same 10 and 10. And if our figures was 10,000 and 800,000, then you would say, yeah, it is 10 and 10, but look at the difference. That is no way this can just be a sampling problem. Right? That's huge. Just because it is 10 people, you can't discount the difference of 800,000 minus 10,000. So, when the difference is large, it tends to be significant. Even when the sample size is small. So, when the sample size increases, when the observed difference increases, then the data tends to be more significant, and your formula works exactly the same way. Your formula will validate this at every point in time. I hope this much is conceptually clear, right? I am now going to go forward and talk about the specific significance testing that we use in market research, and which will cover 90% of the significance testing requirements in market research. Right? I'm going to call it out as 4 or 5 tests, and they'll cover 90% of your requirements in market research. Right, here we are. Let's have a situation 1. We have, let us say, the brand Lux is our brand, just for discussion's sake. Let us say in January, we measure the awareness of Lux, and let's say the awareness tends to be 25%. So it's percentage, right? Then we run an ad campaign for 6 months. We run it on TV, we run it on OTT, we run it on YouTube, we run it on digital, etc. At the end of 6 months in July, we do the research again, and we find that now the awareness is 48%. So the question is, the awareness has increased. Can we conclude that the campaign has had an impact? But immediate question as a statistician would be, do we know that this difference of 35 to 48 is significant? Maybe it is just a random sample phenomenon. Maybe it's not significant, right? So we have to measure. So let us say this sample size is 150 and this sample size is 150. So now there's a formula. In this situation, we have to run a test of proportions. Because 35% is a proportion P1 equal to 0.35. 48% is a proportion P2 equal to 0.48. Right? So the difference is 0.13, and the sample size is involved on 150 and 150. We have to find out whether this difference is significant given the sample size combination. Right? So we have to do a test of difference in proportions. Now, the textbooks will give you a formula, Excel will give you a result, SPSS will give you a result, right? And time permitting, we'll actually teach you how to do it in SPSS as well, maybe in the next session. But at the end of the test, you will get a p-value, the probability of this difference occurring given the sample size of 150, 150. Now, if that probability, hypothetically, if that probability turns out to be 0.03, then we can conclude that the awareness after the campaign is different in a statistical significance sense from the awareness before the campaign. All the test is telling you is that the two awareness figures, pre and post awareness, the difference between them is statistically significant. Now, is that difference because of the campaign? The test doesn't know that. We as marketers will have to then see what else has changed in the market. We have done a campaign, yes, but has anything else happened in the market as well? Or can the entire difference be attributed only to the campaign? Right? So that is a marketing job. It's a market researcher's job. It is not the statistician's job. The statistician cannot give us the result. Right? Having concluded that, the next question will be, we spent 1 lakh rupees and we got a difference of this much. Fantastic. But we spent 10 crore rupees and we got a difference of this much. Terrible. That's not good enough. So the ultimate decision of as a campaign being effective is still a managerial decision. It's still a market researcher's and a brand manager's decision to conclude, saying, has the money that I've spent, has it given me adequate results or not? All that the significance test can tell you is whether the awareness figure pre and post campaign, whether the difference between them is statistically significant or not. Right? It can't do anything more than that. The job of significance testing ends there, which is also why it keeps stressing that market research is a lot more than just statistics and a lot more than just significance testing. Right? Now, I'll just point out one more concept that you need to be familiar with here. I have kept on saying, I have not said I'm testing whether 48% is larger than 35%. I've only kept on saying I'm testing whether the two are different from each other. So, because I'm testing whether they're different from each other, I am running what is known as a two-tailed test. I can also run what is known as a one-tailed test, which is I'll test only whether this is larger than the other. But that's a little more conceptually difficult to formulate in terms of hypothesis. So I normally prefer to work with a two-tailed test. Right? Now, there are two terms that you should understand here. There's something called null hypothesis. In fact, hardcore statistics professors would have asked me to explain that first, but I believe it's easier to understand this concept first. Null hypothesis and alternate hypothesis. So what is null hypothesis? We write it this way, H0. Right? So H0 is that the two are not different. So H alternate is that the two are different. So when the probability is less than 0.05, what we are really doing is we are rejecting the null hypothesis. We are rejecting the possibility that the difference we have observed could have come only due to chance. Is all this clear? So in the process of explaining this test, I have talked about the concepts once again. So this is test number 1. Test of difference in proportions. Brand awareness is a proportion. Brand usage percentage is a proportion. Right? Percentage of satisfied customers is a proportion. Right? Any data that is showing as percentage, a proportion test can be applicable if other things are also relevant there. Right? Let's go forward to the second kind of test. So this is test 1. Right. So let's go to the second kind of test. So we did a study amongst 200 MBAs and 200 engineers, and we found the average income as 10,000, and now let's say 11,000. right? Now this is an average income. So it is equal to mean. So we have a mean 1, we have a mean 2, x bar 1, x bar 2. Now this is a test of means, difference between means. Independent sample. Now what do we mean independent sample? These are 200 separate people. These are 200 separate people. So there are 2 samples altogether. So they're called independent samples. Sample 1 is given as a main figure. Sample 2 is given as a main figure. So there's a formula which we can apply. We can feed in the sample size. We can feed in the mean figure that we've got. We have to feed in the variation, the variance 1 and variance 2, or the standard deviation 1 and standard deviation 2 as well. There are methods to calculate that. We have to feed in those things, and the software will tell us the probability that this difference that we have found of 10,000 and 11,000 has occurred due to chance. So the null hypothesis is that there is no difference. The alternate hypothesis is that there is a difference. These are textbook things, null hypothesis. You don't even need to write it. You can just calculate the probability that the difference between 10,000 and 11,000 has occurred due to chance. If that probability is 0.07, then we conclude that the difference between 10,000 and 11,000 is not due to chance. Excuse me a minute, I just have a sip of water and come. Clear so far? This is test 2. Test of difference between means given independent samples. Remember that. Because the next one is test of difference between means dependent sample. I'm sorry, I'll let it pause and come back in a minute. I'll actually record this, upload this recording and come back in a minute.